So what I'm going to do now is I'm going to run some API comments for registering non-fungible token and listing non-fungible tokens that you as developers going to use. But I'm going to do it from the Daemon interface, and then after that I'm going to show you some code that calls the same API from the code side. And the examples that I'm going to use are similar to how the Ethereum non-fungible token started. So as probably you know, when CryptoKitties appeared, they gave the rise to this to awareness and understanding of non-fungible tokens. It was like a use case, a simple use case, a game that lets you register some assets, digital assets on the blockchain and trade them and et cetera, et cetera. So we came up with an idea of a crypto collectible game called Kryptonites. Like we have Crown platform and we can create crypto collectibles where you're gonna own different knights, right? On the blockchain, you can also later at the later releases trade them and update them, etc., etc. So you're not gonna see like nice pictures or anything today, but let's just imagine this concept so you can understand it. And this example I'm gonna use to show you registration through the simple command line interface. So before going forward with that, I want to explain you a couple of things about non-fungible tokens on Crown. And I also assume that you know what testnet is and mainnet is. And what I have here on my laptop is like a local testnet. We call it a sandbox. And this sandbox has 3 nodes. And you, as an engineer, will be able to run the same sandbox on your machine if you want to quickly create your app and test it. And I'm just going to use this script sb.sh to run comments on my wallet, which is running locally. And it's all the same as in your Bitcoin wallet, but it's just from the command line. So I'm just gonna list all existing tokens on this node, on this blockchain, this local sandbox blockchain. And I'm going to go step by step through these properties of each NFT, and more importantly, the most critical ones. So the most critical ones are non-fungible protocol ID and non-fungible token ID in general. So when you have a non-fungible token on Ethereum, you have some specific ID that uniquely identifies your token in your smart contract. For example, if it's a CryptoKitties smart contract, you have every CryptoKitty has its own ID, and this ID can be something like a DNA of this CryptoKitty. For you as engineer, it's your decision how you're gonna decide what the ID is about, how it's represented, but it must be unique in the set of your application. And how application is identified is by the protocol ID. You can see that here we have a doc, which stands for document, and the idea is that I create a hash of a document, write it down on the blockchain. But in reality, it can be anything, and you can just come up with a name, and you can think about it as a symbol, like on Ethereum when you create a classic fungible token or an ICO. So it's just an identifier. It's a readable identifier that uniquely identifies your application. And on the whole set, of non-fungible tokens on the Crown blockchain, the protocol ID and token ID both together uniquely identify each token. That's important to understand as a developer, and how the architecture is created. So these are just sample tokens that are registered, and we don't need to like go into the details about these ones. Another thing I want to mention here is the metadata. And in the case of Kryptonites, for example, or CryptoKitties, it can be some additional information about your asset on the blockchain. It can contain, for example, a name, a description, or a link to an image, etc., etc. Something that describes your asset. Either it's a digital asset or it's a digitalized physical asset. So what I'm going to do right now, I'm just going to run a simple comment of registering a Kryptonite, and I'm going to use web application to calculate the hash. And the hash is just basically 256-bit number, so it can be anything. And in the case of CryptoKitties or Kryptonites, it should be some kind of DNA that is in the core of your application. And I just wrote down sample numbers that might uniquely identify it. And for simplicity, I just calculate the hash. And this is my ID for my first Kryptonite, okay? So right here, I'm just gonna type, let's say, just pretend that it's in your wallet, and you're in your command line, and you're gonna write down NF token. You can use the word register or issue. It's really up to you. The next thing you gotta write down the name of your protocol. And in this case, it can be like a Kryptonite, okay? I need quotes actually. So this is the ID, and also I need to prove the ownership of this asset, and for that I also need to generate an address, and need to run a command get new address. Okay, and I'm gonna run it again because we have the owner address and we also have the administrator address who can, change metadata and stuff like this. So going back to the registration process. Kryptonite and our ID and the ownership key and the administrator key. And here I'm going to write down some metadata information. For example, name can be Percival, and description, the most I don't know, scary night, something, and image can be some kind of URL. Doesn't really matter. So, and I run it, and what you have here is the transaction ID. You just, right now, I just paid a small fee for registration, and the special transaction just was sent to the network. And with the next block, this non-fungible token will appear on the blockchain and will be visible if you want to list when you list all the non-fungible tokens, right? So if I'm gonna run the listing command that I ran before, it's probably not going to be listed before the next block is mined. So let's just check it. Oh yeah, it's already mined. So here we see this new token. And this is what I do as a user, right, from the side of the console. But you as engineer can take the same thing and integrate the logic in your application using this API. So you can issue new application as a protocol ID, and then you can start registering kryptonites, and people can own them, and people can later trade them, upgrade them, etc., etc., etc. And the simplicity is that you don't need to write any Solidity code, and you know exactly what you need to do to implement the idea in your application. So it's kind of more data-oriented approach where you cannot really customize your code on the chain, you run it off chain, but it's easier for you to implement something like that. So other APIs that you can use, you can get an exact token, which stands for like get, and you use kryptonite and the address. So you, in this case, you just get one of them. All right. Oh no. I put the address and I had to put the ID. Okay, here we go. The other options that are available, you can get a total supply of each protocol ID. You can, what do we have? Yeah, you can get a balance of any owner on the blockchain, and you can also find out about the owner of the specific token. So basically, as engineer, you have access to different calls where you will be able to write down stuff on the chain or read it from the chain and display it on your front end from your back end. All right, so this is the example that I just showed you from the side of the console. And I also prepared an example, like a reading code. It's written in C++. It's just a really simple example where you write down the code and you register a hash of some information, of some document. And in this case, the idea is, for example, that I predict the price of Crown or Bitcoin for 2020, right? And I think, for example, that like Crown will cost $200 in 2020. And I just calculate the hash. And for example, Hasse has a different opinion and he thinks it's going to cost $1,000, and somebody else has another idea. So we all can register our predictions as non-fungible tokens on the chain. And we can prove that we had this prediction, and we can also prove the ownership and authenticity of that. And when the day comes, we can compare our predictions, and the one who has the closest guess can, for example, win, I don't know, like 1 Bitcoin, and we all together put the Bitcoin in a multi-sig address or something like that. Just a use case to show you. And I'm gonna put it down right here. This is the hash, and later this example can look like just as a simple application that you're gonna use to register anything, any information as a token on the chain using the protocol doc, for example, right? So just gonna run it. This is my IDE. So, and the program just finished working, and we have a registered a non-fungible token, and this is the transaction ID for that non-fungible token. All right. So now, if I go back to the console, I will be able to show this non-fungible token registered on the same chain as soon as the next block is mined. So I'm gonna go here. I'm just gonna list all of them. And you can see the new non-fungible token with the protocol ID doc with the same hash, which stands for this prediction. You can see it's the same, and the metadata information. So these are two simple use cases of how you can use non-fungible tokens on the Crown platform. And you can come up with many different ideas, and there are people with ideas who want to start building apps. It's important to understand that it's not like a D app, it's more of a kind of hybrid app where you have off-chain logic and on-chain logic. So I'm done with this demo, with this part of the demo. So if you guys have any questions at this point,